Hello everyone and welcome to the last video of this year. Before we move on to today's problems, I want to pause for a second and uh, take a look at where we are right now in the process. So as you might know, I'm going through this grand 75 questions list. I'm almost done with this list. I've done week 2 is done, week 3 is done, week 4 is done, week 5, week 6. There are some questions at the end. Just need some revision with them. As soon as I'm done with them, I'll tick them off. And from the recap video, lead question recap video we saw in the last video, I got to know that I have solved 85 problems this year. 85 problems, and I started it in June. Yeah. I started. There are some in May. From 1st June, so 7 months and 85 problems. Here it says 92, but that's I think the total problems. So yeah, 7 months, 85 problems. I think that's a good number. Considering that I usually attempt a problem several times, usually 3-4 times, with sufficient gap between each attempt. And I think that's a really good way to go through these problems, because well, first of all, it's a lot better approach than solving a problem and just then move on to next problems. For me, what I have found is that I literally forget everything the next day, so it's really very helpful for me when I go back and do the same problem again. Usually Anki handles all that for me. So very good, great tool. So yeah, I've been consistent, more or less. I've been a lot consistent last 3 months. Well, I thought I was doing more than this. Okay, so yeah, good number. I mean, I don't plan to do 400, 500 problems. Those big numbers. I would rather do fewer problems, but do them properly. So that has been my approach. And then obviously the next step is to extend this list and start once I've reviewed all those remaining questions, start doing problems from the extended list. There are total 169 problems, minus 185 already done. So yeah, I'm almost halfway from finishing the entire list, and once I've done all these 169 problems, I'm done. Yeah. So yeah, now I am hoping I'll be able to finish this entire list within next 6 months, max 6 months. It'd be easy now. Now I've gotten the gist of how to go about these problems. And after this, I'll finally be done with lead code. So yeah, and I don't really plan to start any other list after this, because I mean going through this one is hard enough. So yeah, this was okay. This was some plan. First problem of the day: serialize and deserialize binary tree from the revision problem. Serialization is the process. Okay, this is the process we turn objects in the programming language into bits, so those zeros and ones, so we can send them over a wire to other computers. That is what serialization means. Converting a data structure into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network and can be reconstructed later on the other end. Design an algorithm to serialize and deserialize a binary tree. There are no restrictions on how you serialize and deserialize algorithm. How your algorithm should work. You need to ensure how a binary tree can be serialized to a string. You just need to ensure that a binary tree can be serialized to a string, and this string can be deserialized into the original structure tree. So yeah, basically this list into converting this tree node into a string, and then deserializing that string to get a tree back. Which tree algorithm should we use? Which tree search should we use here? Well, if this is a tree, let's see, depth first search. We start from the root, we go visit the left subtree, and then we visit the right subtree. So root, right, left. Pre-order. So okay, one denotes our root, and then left, and then we also have to store null. Look for null. So right, and there is no node below 2, so null, and one more null for right, and then we visit the right side, so 3, left side 4, null, null, and then we come back at 3 and visit the right subtree, null, null. And to get our tree back from this list, we can make use of a queue. yeah, breadth first search. Depth first search, breadth first search. To convert it into a string, we will use depth first search. To get a tree back, we'll use breadth first search. So once we have this string with us, we can just say, okay, add the root to the queue, make the node, and then just process the right side, usually the next element in the string. So after 1 there is 2, process 2, and then there is null. Can we do without nulls? Okay, serialization is easy. Deserialization is not that intuitive, but I think with some trial and error I'll be able to get it. So yeah, we will use a string builder, new string builder. I wanna say let's create a helper function, private void string, void serialize root node and string builder. If root is null, we want to append a null else sp dot append the value of the node and a space. Space because later on we can split our string from spaces. And then usual checking the left side, serialize root dot right, checking the right side, and yeah, that's it. When do we return? Well, we return here. So yeah, let's see. Let's check the output. Root and sp. Return string builder to string. Okay, and for now, let's just new renode. 0, right? Okay. So let's check if my string builder is getting created properly. System println sp. Null. Why null? What's happening here? Oh, why am I getting 2 lines? What's happening? We don't need it. The cells here. Okay. We need root at the 0th index, and according to my logic, yn yn system.out.println root's value and print this first. Okay, it is working fine. The first search is working as it is expected. Then why is not string builder getting created properly? Fruit is null. And then you add a. Let's observe the string builder in this function. SP. Okay, so now there is no null. There should be a null after. There should be two nulls in fact after. Hang on. You want. Oh. We want one, then two. Oh my god. Oh. This is why I should read the question properly. But we haven't got into this deserialize yet. And it's good I noticed it here. I would 100% would have messed this up later on. Okay, so we want root, left, right, level wise. We should also build. We should also traverse the tree level wise. Right? Yeah. But I remember I did it differs. I serialized it using the first search only. The first search only, so I just want to know what's wrong with this. 0. Data at 0th index. What? Yeah, it's a string. The chart 0. Chart. 49. What? Oh yeah, we need to spread the data. Hey. Void. Node deserialize. 49. Splitting the data should return me a char. Data is data dot split at data 1. This is an array. Root. Just show me what the root is. Split. Okay. Yeah, okay, it will return a string. Okay. Then I can need to declare a separate variable for that. Char it. Char it. Char it. Char it. Char it. 0. So that tells me how much practice I really need. Yeah. At some point you is integer dot parse or string dot parse. Cannot find the same. Was it string dot parse? String dot parse. Was it uppercase? Okay. I think I looked it up. What's the correct method for converting a string value to an integer? Partial. Okay. Yeah. Partial. And for some reason, okay, hang on. N. For some reason, we have N at the start. So dot N data. Standard output 1. 1. What does 1 mean? Root. Mm. Mm. Oh God. How can I make such a silly mistake? This is the right order. Uh, root 2 null null pre-order pre-order. So in pre-order, we have let me just revise my basics. Pre-order is left, root, pre-order, right, in order. Well, pre-order is root, left, right. In order is left, root, right. Post order is left, right, root. In order. Mm. Pre-order. So we're doing a pre-order search. Left, so root, left, right, root, left, right. Pre-order search using depth for search. Okay, on to the serialization. Well, this is the data we get, and let's just play around with queue for a second. Queue, new linked list, and I'm going to add 0th element into my queue. Now should I add the value of string, or should I add, or should I first make a node from the value and then add that node in my queue and then do some kind of processing then? Okay. Are we going to have problem here? Because okay, we process this one. Process 1 means make a node from 1, and the next is 2. That is right child. There is left child. 3. This is string decoded. Coded data dot split at spaces. Root while queue is not empty, root is equal to new tree node and queue dot poll. We also need the size of the queue dot size, so we can run a loop int I is 0 as long as I is smaller than size, increment I. So currently we have only one element in the queue, so this loop will run one time only. Now whatever we do in this loop is going to decide. Okay, what we want to do next? Well, we want to look for the left and right node. If we come across a numerical, then we can add it to the queue. But how can I handle null? Do I set that root dot left? How can I know? How would I set it to 0? How would I set it to null? Root null. Well, and if I'm going to, I need to maintain a current. I need to maintain a pointer. Well, once we have set it to 0, then we will set the root to root dot left. Well, I don't feel this is right way. Well, I'm not worried about this. Here, 2 nulls are coming after n, after 3, but that is only because of the way they are printing it. We have actually 6 nulls. 1, 2, and 3, 4, and 5, 6. Should we really need that many nulls? Hmm. Okay. Well, we know the first element is root. We know the second element is left subtree. Because this was depth first search. If we find a null, how should I signal? How should I tell my root? Okay, we have found a null. Now we are not looking in this branch anymore because I've confused depth first search and depth first search and breadth first search completely. I need to construct my tree. I'm using a breadth first search, but my can I reverse? Would it work if I reverse the string? Okay. We don't. Okay. 2, 3. No. 2. Null. So 1. It starts with 2. What is this? Null. 2 left, then right, and root. Left, right, root. Left, right, root. Root. So 1, 3. Something's not quite right here. Well, it just remembered that I could reverse the data string. So what form would I make my string into so that when I reversed it, it should give me, I don't know, the right order. Okay, give me a hint. Wasted so much time. Let's get the hint from my submission. Almost 15 days ago. Well, fruit is null. Okay. Things are all right here. For some reason, I think this line is important. Haven't had problems. Okay. It's same. Same. Okay, so we're serializing this string, right? Then why is it so hard to come up with deserialization? Okay, well, let's see. 1, 2, 1, 2. I don't need Q here. Q arrays as list. Depth for search. So we're doing depth for search anyway here. Data all. Okay, we have Q just to get the next element, not for breadth for search. Interesting. Aris as list. I didn't know. I did not know about this API. Like, I forgot about this API. Hmm. Hmm. But yeah, it's very easy. It's pretty easy. Not that difficult. Hmm. Okay. Let's just submit this so that it can show here. The last solution was on 14 December, 31 December. We'll come back to this one in a couple days. Okay, thank you so much for watching, guys, and yeah, wrapping up this year with a problem I couldn't do. Yeah, bye.